All right, so in this video, we are going to take a brief look at exactly what is a graph. So after watching this video, you should be comfortable describing what graphs are, the different components that make up a graph. You should be able to talk about why graphs are actually useful and draw some of your own examples. So, first things first, what is a graph? A graph is simply a collection of data that is represented by nodes and connections between those nodes. So you've probably actually already used or implemented some type of graph. You can think of graph as a very broad term, and there are lots of specific types that kind of fall under the umbrella of a graph. For example, trees can be considered a type of graph. So if you've worked with trees, you've worked with graphs. Some of the different components that are required to make up our graph. We have the nodes or the vertices that represent pieces of data in a set. So for example, if you have a map and you're representing some kind of location as a graph, the cities might be your nodes. You could also have maybe an animal hierarchy with different animal groups, or you could have nodes that represent different pages on a website. And then your edges would be the connections between all of those different pieces of data. So kind of going with the city example, the edges might be the roads. Thinking about animal hierarchies, you could have the more general animal groups at the top and edges showing all the different animals that fall under that group. So for example, you could have a node that represents mammals and then edges connecting mammal to all the different subclasses of mammal. And with web pages, your edges might be, okay, from page A, what pages do I actually have the ability to get to? And then an optional component that you will see in many graphs is a weight or a cost. So not all edges are created equal. So sometimes it might take more time or more resources or something of that nature to get from one node to another. And we can represent this using a weight. So let's look at an example. So here we have a graph that has 6 vertices. So we've got V0, V1, V2, V3, V4, V5, and we have lots of different edges connecting these different vertices. Okay, and each edge has a weight assigned to it. So if we were actually going to implement this graph, typically the way we implement graphs, it's a couple of different sets. So first of all, our graph, we have a set of vertices, okay, a set of nodes that our graph contains, and we also have a set of edges. Those edges are represented by the 2 nodes the edge connects, and then that third attribute, that weight attribute, is again an optional element of our edge. So what are graphs useful for? What is the point of actually taking a set of data and turning it into a graph? Well, there are lots of real-world scenarios that we can visualize with graphs, and then we can use graphs to do different operations on. So for example, a city or a country or some type of location, okay? So this example here, we've got the BART line in San Francisco. So we can represent all the different possible stops that you could get off with or get off at using different nodes. And then the different trains that you could take from one stop to another. We could think of those as the edges. Each of those edges, maybe it has a weight, like how much time it takes to get from one stop to another. And you could then use that graph to calculate, okay, what's the quickest way to get from, I don't know, Richmond to the San Francisco airport? Which line should I take? Okay. We can also represent networks of activity as well. So this example is maybe a little bit less intuitive, but for example, on GitHub, if you are looking at the history of push, pull, request, commits, etc. for a particular project, GitHub actually represents this history using graphs. Kind of a cool application. And then anything really that you can represent as some type of network. So for example, a social network, a physical network, like maybe like a network of cell towers or things like that, we can represent using graphs. Okay. So let's look at a few examples of some specific types of graphs. So some graphs are directed. What does that mean? That means the edges in this particular graph, you can only move across them in one direction, and which direction you can move is indicated by an arrow, right? So this graph is representing a website, and it shows very clearly, okay, from home, there's only one place you can go from the home page. You can only go to the Learn More. There are several pages that allow you to go back home, okay, etc., etc. But you cannot go both ways across these edges. This is different than an undirected graph, which allows you to move in both directions across an edge. So this could also be referred to as a bidirectional graph. So there are more options when you think about, okay, how am I going to traverse this graph? And both of these graphs that we're looking at here are examples of weighted graphs. The edges have weights assigned to them. Additionally, we can also classify graphs as cyclic. So what does that mean? Think cyclic, cycle, something that repeats, something that you do more than once. So a cyclic graph is simply a graph that allows you to revisit at least one of your nodes, one of your vertices, more than once. So for example, if I had a graph representing some type of cycle like the water cycle, okay, there are states that I will revisit multiple times. So this would be considered a cyclic graph. And also looking at this particular example, there are no weights on the edges. So we would classify this as an unweighted cyclical graph. Okay. Or we can have an acyclic graph, which simply means that nodes can only be visited one time. So for example, if you turn your favorite recipe into a graph, it's possible that there are steps that need to be done once, only once. If you do them multiple times, things are not going to end up well. So like if I am making pancakes, I do not want to repeatedly heat the syrup, or I don't want to repeatedly add, eggs but not more milk, things like that. So I have states, I have nodes that I only want to visit one time. Okay. So to sum all of this up, so a graph is a very broad term that encompasses any data that we can represent with a set of vertices and edges that connect those vertices. And it's useful to represent a variety of different types of relational data, but it's particularly useful for representing different networks, both physical networks and conceptual networks.